Okay, now it's time for Circles 102 practice problems. So, we're going to practice problems that have to deal with the segment lengths inside circles cut up by all these different shapes that we had. So let's take a look at this set here. And refer to this circle P for exercises 6 through 8. And we're told that AX is equal to BX is equal to 20, and that TX is 6. How long is TS? Ooh, that's the whole thing. So I have, this is 20, and this is 20, and I know this little strip right here is 6. Well, according to the theorem we have, if I have two chords that intersect inside the circle, they divide each circle up so that the products are equal. So the 20 times the 20 has to equal the 6 times SX. 20 times 20 is 400, and I get 6 times, I'm just going to call it X for now. So 400 equals 6X, so 400 divided by 6 is X. Well, 400 divided by 6 is a pretty large number, so to speak. It's 66 2/3. But do I want to find X? No, I want to find TS. Well, TS is the TX plus the XX. TS is TX plus XS. Well, this is 6. This is 66 2/3. So if I add those together, I get 72 2/3. Okay, so that's one problem. Sorry about that, I didn't actually get into the board. Okay, so now what if AX and BX are both 15? So now these are both 15. And we know that TX, again, this one here, is 5. How long is the whole thing? Are you seeing a pattern here? So I'm going to take 15 times 15. That's going to equal 5 times XS. And again, we know that TS equals TX plus XS. Well, TX is 5, and I don't know what XS is. So if I solve this out, I get 225 over here, and I get 5, and I'm going to call it X again. So if I take 225 and I divide it by 5, I get X. Okay, 225 divided by 5 is just 45. So that equals 45. If I add 45 there, the whole thing is 50. Okay, I'm not going to do the third problem there. I think you could do that on your own. So let's move on to a different type of problem. In circle M, diameter AF is 42. AC happens to be 36. AB happens to be 42. AC is perpendicular to MB. BA and BC are both tangents to the circle at points A and C respectively. Wow, that's a lot of information there. Okay, so I'm going to take that information and put it up here. I know that AB is 42. And because AB and BC are both tangents from the same point, it also has to be 42 because the two tangents have to be the same length. Now, I was told the whole thing from A to F was 42. That means F to M is 21, and A to M is 21. And I'm told that AC, the whole thing here, is 36. Well, since MB is perpendicular to AC, that means it cuts it in half. Since it cuts it in half, that means I can make each part of this 18. So I got an 18 and I got an 18. Okay, so that's all our given information. And we know it's tangent, so that means I'm perpendicular here and I'm perpendicular here. And CM would be 21 and GM would be 21. MD would be 21. All those radii are going to be 21. Okay, so we got a right triangle there. Let's see, can I figure out how long MB is? Well, yeah, I see I have a right triangle right here. So, 21 squared plus 42 squared has to equal MB squared. 21 squared is 441. 42 squared is 1,764. And if I add those two together, I get 2,205. That's my MB squared. So if I square root that number, I get 46.96 for my length of MB. Okay, so I figured out how long MB. The whole thing would be 46.96. Okay, so I've got that segment done. What I don't know is I don't know how long ME is, or ED is, or BE is. So I don't know that. But I can figure out dB real easy, right? Because dB, MB equals MD plus dB. Do I know MD? You betcha. Do I know MB? Yes. That's our 46.96. Do I know MD? Well, yeah, that is a radius of the circle. So that's going to be 21. So now I'm just looking for dB. Can I figure it out? Ooh, probably. dB has to be 46.96 minus 21. Or around 25.96 would be dB. Well, now that I know dB, can I figure out ED? Or EB? Or ME? The three I got to find here yet, I can't figure out just based off of this information. So what do? Tougher problems. I have to go back to the fact that if I have two chords that intersect inside a circle, their products are going to be the same. So let me erase all of this for a minute. We don't need any of that. Don't need any of this. Okay. I'm going to draw in this whole thing right here. So now I have E all the way over, let me see, what should I call this? I'm going to call it H. HD is a diameter, so it would be 42. Okay, let's let ED be X. So ED, let's let it be X. That means ME is 42 minus X. Now, I do know that A to E and E to C, we already figured those out. Those were both 18ths. And according to our thing, if I take 18 times 18, one chord is two products multiplied. It has to equal the other one. 42 minus X times X. So if I clean this up again, 18 times 18, I think it's 324. And on the other side, I get 42x minus x squared. Because I have an x squared, I'm going to move everything to one side of the equation. So I'm going to move the x squared over by adding. I'm going to move the 42x over by subtracting. So I get x squared minus 42x plus 324 has to equal 0. So this will tell me what the x is if I figure out that equation. And that x will just tell me how far it is from E to D. After I figure out what it is from E to D, I can figure out all the rest of it. Because we've already figured out what dB was. It was 25.96. And we could add that value on, and I can figure out what the ME is if I take 21 minusing whatever that x is. So I'm going to have all the rest of it. I just have to figure out what x is here. Well, that leads us to an interesting problem. If you think all the way back to algebra, you had the little thing called the quadratic formula. And it said, for any quadratic equation a quadratic equation, put it in there, ax squared plus bx plus c equals 0. Kind of like what we have up here. Semicolon. X will equal opposite of b, add and subtract the square root of b squared minus 4ac, all of that, the whole fraction, divided by 2 times the a. That's if we couldn't factor it. We could always go back to this little quadratic formula. I want you to make sure you have that written down in your notes. That is something you're going to have to use on the assignment. Okay, so in this case here, my A is 1, my B is a negative 42, and my C is 324. So now to figure out what the X is, I just have to use the formula. x equals the opposite of b, so that means it's a 42. Add and subtract the square root of a negative 42 squared minus 4 times our a is 1 and our c is 324. All that divided by 2 times 1. So now what I do is I clean up what number is inside the square root. So I'm going to take the negative 42 and square it. That should be that 1700 number. And then I'm going to minus 4 times 1 times 324. I get 468. And all that has to be divided by 2. So this means I got 42 plus or minus, well, the square root of 468 is like 21.63-ish. Divide all that by 2. Okay, so now I'm going to go ahead and add them. If I add them, hold on a second, I'm storing the number. I'm sorry, okay, we'll just take what I got there. So 42 plus 21.63 equals 63.63. If I divide that by 2, I get 31.815. Taking a look at our figure there, that doesn't seem to make a whole lot of sense. So let's go ahead and subtract them. 42 minus the 21.63 gives me 20.37 divided by the 2, and I get 10.185. So I'm thinking that's probably a better estimate for my figure here, but both of them could be correct. Now let's see, if I go back to my figure, okay, this value here could be 10.185, or it could be 31.815. Well, if I add those two numbers together, I get 42, which is a good thing because it tells me that either the x is the 10.15 or the 3.15, or, which is probably a better idea, is that this side over here is the 31.815, because the e is between the m and the d, which means it's on the short side of the equation there. Okay, so now I have my whole diameter there, right? Got it? I got the whole thing figured out. The whole thing is equals 42. Now I know all my numbers. I know e to d is 10.15, 10.185. I know my e to m is 21 minus 10.185. Or it's the 31.185 minus 21. So it's 10.815. My EB is going to be my 10.815 plus, 185, plus our 25.96 that we found earlier. So it's 36.145. So we have found every length in this figure. Every length. We can find out every one of them. The only one we haven't done actually yet is GA, but that doesn't matter because we weren't asked to find that one. Okay, let's move on to a different type of problem. Let's say WX is tangent and WR is a secant segment. So now we're told that ER is 16. So this right here is 16 and WX is 8. Oh, that's 8. All right. And we have to find WE. We're trying to find this WE. Let's call it Y so I don't get things mixed up. Okay, how am I going to do that? I have a secant segment and a tangent segment. Hey, that's one of our theorems. It says if I take the whole secant segment times just the portion that's outside, that has to equal the tangent segment squared. Okay, so let's see. The whole segment here would be y plus 16. The outside portion is just y, and the whole tangent is 8, so 8 squared. So if I look at that, I've got y squared plus 16y has to equal 64. So y squared plus 16y minus 64 has to equal 0. I have another quadratic equation to solve. I could try to factor it. I can try to find two numbers who multiply to be negative 64, and then when I add them together, I get a positive 16. Seems like a piece of cake. Or I can use the quadratic formula. I'm going to go with the quadratic formula again. My a is 1, my b is 16, and my c is a negative 64. So that means my y has to be a negative 16 plus or minus square root 16 squared minus 4 times 1 times a negative 64. Now the interesting thing about here, I got this minus 4 times 1 times a negative 64. I've got two negatives there. That's going to actually end up becoming bigger. And all that has to be divided by 2 times 1. So that tells me I got a negative 16 plus or minus, let's see, over 2 square root. Let's see what we get. 16 squared is 256. And then I got to subtract 4 times 1 times a negative 64. So I get 512 here. And the square root of 512, sorry about that, is 22.6. So I get a negative 16 plus or minus 22.63. All that divided by 2. Well, if I do the minus, I get a negative 16 minus 22. I get a big negative number. Got a problem with that? I do, because I can't have this length WE, which is the y, be a negative value. So the only one that's going to work here is the plus. So that means this is going to be a negative 16 plus the 22.63, or the square root of 512. So let me add a negative 16 to that, and then divide that by 2, and I'm told that y is approximately 3.3. So my y is approximately 3.3. So my WE is approximately 3.3. So we found that one. Nice, simple problem, as long as we could use a quadratic formula. Okay, let's go to a different one. I think the other two are similar in that they give us the same bits of information. Let's see what we get. Okay, number 10, WE is 20. So I know the outside is 20. ER is 5. And I'm trying to find WX. And let's see, the other one says ER. Okay, so 11's a lot like 10. They just changed the numbers up on it. Okay, I got to make that add to 5. Okay, so now we know that I got to take the whole times the outside for any secant. That's what I'm going to do. Is going to be equal to the tangents squared. Okay, the whole here is 20 plus 5, outside plus the inside, times what's on the outside, that will be the 20. And that'll equal our tangent, well, let's call that y this time, y squared. So 25 times 20 gives me 500. So 500 is y squared. And if I do the whole square root thing, and anytime I do that, I could actually have positive or negative numbers. Square root of 500 gives me 22.36. It can't be a negative in this case, so I would say WX is the square root of 500 to be exact, and around 22.36. Now, number 11 is going to be done real similar to that. It gives you the ER and the WE, and it gives them what you do to find the WX. Okay, so that's a secant and a tangent. So now let's move on to a problem where we've got multiple things in here. We've got a tangent. I see a couple of secant lines. I see a couple of chords intersecting. This could be a real interesting type of problem here. Okay, we're told that AB is 5. So I'm going to go ahead and put that on here. AB is a 5. We're told that BC is a 4. And they want us to find EC. Hey, that's just like the ones up above. I've got a secant and a tangent. So that means a whole times an outside has to equal the tangent squared. So 5 plus 4 is the whole, times this on the outside, which is a 4, will have to equal our x squared. So that one's going to be the square root of 80. Or just under 9. Okay, so we figured that one out. That one wasn't that bad. Let's take a look at the other one. HC is 3. AB is 4. BC is 2. Okay, that's just dealing with the two sequences, it looks like, and I need to figure out what DC is. Okay, so here I have two secants, and we're told in our theorem, whole times outside has to equal whole times outside. That's what our theorem told us. So my whole, let's do the AC here, would be 4 plus 2, and my outside is 2. Now for the other one, the whole is my x. I don't know it, and my outside is 3. I just have to figure out that problem. So on the left I've got 12, and on the right I got 3x. So it tells me x must be 12 divided by 3, which is 4. So x is 4, which is DC. Now what if they had asked us what is HD instead of DC? Well, I can do that same way. I can figure out what DC is doing by what we just did, because HD would equal DC minus HC. So DC was 4 minus 3. HD would have to be 1. Okay, so those are sample problems for Circles 1.2 type of problems. Good luck.